Alright, so section 13.3 is on using the sum and difference identities, which are on the bottom left right there. So basically what you have to do with these is take the angles given to you and find a way to make them out to be the sum of two other angles. Okay, so these are the three most important angles that we want to try to make sums out of: 30, 45, and 60. And if we can't make one of those appear, we'll make one of those appear in terms of its reference angle. So I'll show you what that means. So if we look at 165, it ends in 5, so that's usually a sign that 45 is going to be involved there. And 165 can be written as 120 degrees plus 45 degrees. Okay, this means we're going to be using this identity right here, the cosine sum. So the formula is, this is our A value right here, and this is our B value. So if we split that out, we're going to get cos 120, cos 45. And then when you're adding for cosine, you end up subtracting these minus sine 120 times sine 45. Okay, so now we need to calculate each of these. So first of all, cos 120, if we draw our unit circle right here, 120 is going to put us about right here. And the reference angle for 120 is 60 degrees. So we're really being asked to find the cosine of 60 just with one catch. We're in this, 120 puts us in the second quadrant. And this acronym, all students take calculus, means that in the second quadrant only sine is positive, cosine is negative. So cos 120 is really like cos of 60, except the negative version of that. Okay, the cosine of 60 degrees is equal to 1/2, and it's going to be negative 1/2 because we're in the second quadrant. Cosine of 45 is equal to root 2 over 2. And we have minus, just let me clear this off for a sec. Get some more space there. Okay, and then same thing over here, the sine of 120 is also like the sine of 60, but it's positive because we're in the second quadrant. Sine is positive in the second quadrant. Sine of 60 is radical 3 over 2, and sine 45 is radical 2 over 2. So if we start to simplify this now, negative 1 times radical 2 is negative radical 2. 2 times 2 is 4. And then we have minus radical 3 times radical 2 is radical 6, and 2 times 2 is 4. And the last thing we can do is just pull this basically over the same exact denominator, because they do have a common denominator. That should be the exact value, and that's exactly what they had. They just wrote it with negative radical 6 coming first. Alright, for number 14, I should say, it's probably easier to change these into degrees instead of radians. Most people find it easier to work in degrees because it tends to be more intuitive. So just to recall how to do that, you take the radian value, and there's pi radians for every 180 degrees. So we're going to put 180 over pi. The reason I put pi on the bottom is because pi is on the top right here, and we want it to cancel. 12 goes into itself once, and it goes into that 15 times. So this is actually the same thing as the tangent of negative 75 degrees. Okay, so the question is, how can we make a sum or difference identity using this? And actually it would be easier to figure out what negative 75 degrees is in terms of a positive angle. So negative means that we're going clockwise instead of counterclockwise, so this right here would be negative 75. So the question is, what is this angle right here, this outside angle? And the easiest way to do that is just subtract 75 from 360, and you wind up getting 285 degrees. So the tangent of negative 75 is the same thing as the tangent of 285. Okay, again, if we look at these three angles, obviously 45 would be part of what gets us to 285, and 285 turns out to be 240 plus 45. So that's our sum right there. Now we need to use the tangent sum identity, which is right here. And it looks like this is our A value, this is our B value. So the formula says take the tan of 240 plus the tan of 45, and you divide that by 1 minus, and notice that the minus is on the top right here. So when we're adding values, we have to have a subtraction on the bottom. So 1 minus the tan of 240 times the tan of 45. Okay, so tan of 45 is pretty easy to remember. It's just equal to 1. The question is, what's the tan of 240? So let's draw a circle here. 240, here's 90, here's 180. It's not going to take us quite to 270. 240 is about right there. And so the reference angle is going to be this angle right here that gets us back up to 180, and that's 60 degrees. And then according to this acronym all students take calculus, tangent is positive in the third quadrant where 240 is. So tan of 240 is exactly like tan of 60. It's going to be the same value. So tan 60 plus tan 45, and that's going to be over 1 minus tan 60 times tan 45. And we just need to find what each of these are. So tan of 60, that's equal to radical 3. Tan 45 is equal to 1. And same thing down here, this would be 1 minus radical 3 times 1, which is just radical 3. So if we simplify this, we get radical 3 plus 1, that's the top, and then 1 minus radical 3. This is almost done, but usually we don't want to keep denominators with radicals in them, so we need to rationalize this. So here's how you do that. You multiply by the conjugate. The conjugate of 1 minus radical 3 is 1 plus radical 3. So we have this, then when we FOIL this out, we have 1 times 1. The outside and inside terms will cancel. Positive radical 3 and then negative radical 3 will cancel. And then finally we have negative radical 3 times positive radical 3, and that's just 3, or negative 3. Okay, then the top, when we FOIL out the top, we'll have radical 3 times 1 will be radical 3. Radical 3 times radical 3 will be 3. 1 times 1 will be 1. And 1 times radical 3 is again radical 3. So here's the last simplification we can make. The bottom 1 minus 3 will be negative 2. This radical 3 plus another radical 3 will be 2 radical 3. And then 3 plus 1 would be 4. And the very last thing we can do is just divide everything by 2. So that becomes 1, that becomes 2, that becomes 1. So the final answer would be, we have this negative right here. So negative radical 3, and then we have negative 2 divided by negative 1 would be minus 2. So that is the tangent, negative radical 3 minus 2, that should be the tangent of this original angle. And they have the same thing, they just wrote it in reverse order with the number coming first. Alright, we'll do a couple more here. So sine of 5 pi over 12, we actually just found that. That's the same. 5 pi over 12 is the same as 75 degrees. And 75 can be written as 45 plus 30. Remember that we're looking for those angles to show up, 30, 45, and 60. So the sine formula is right here. So we'd have, this is our A and this is our B. We have sine 45 cosine of 30. This is easy because it's in the first quadrant, plus cosine 45 times the sine of 30. Sine 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. So when you multiply those, you get radical 6 over 4. Cosine 45 is radical 2 over 2. Sine 30 is 1/2. You multiply those, you would get radical 2 over 4. So that's our answer, and then when we combine them into one fraction, you would get what you see right there. Alright, here's our other one right here. So sine of negative 7 pi over 12, when you change negative 7 pi over 12 into radians, you would get negative 105 degrees. We could change it the same as we changed it on the other page. So negative 105, here's negative 90 right there. Negative 105 puts us a little bit past that. So the question is, what is that? It's a positive angle, and a different color for that. So that's the positive angle, that green one, and to get that positive angle you would do 360 minus 105 and you get 255. So we're basically being asked to find the sine of 255 degrees. It ends in 5s, that usually means we're going to end up adding 45 to something, and 255 turns out to be 45 plus 210. And then we use our same formula, so this is our A and that's our B. So the sine of 45 cos 210 plus sine 210 times the cos of 45. Okay, the question is, where does 210 put us? 210, well, there's 90, there's 180. 210 is in this quadrant right here. And so the reference angle for 210 would be this purple angle right here, which is 30 degrees. The only thing is, because we're in the third quadrant, only tangent is positive. So that means both sine and cosine of 210 will be negative. So let's rewrite this. This is the sine of 45 still. This one we just said is like 30 degrees because that's the reference angle for 210. But it's negative cosine of 30 degrees because cosine is negative in that quadrant. So we're multiplying these, by the way, so that's why I'm putting parentheses. This one right here, sine of 210, is like the negative sine of 30, because again 30 is the reference angle, and we still have cos 45. And now we're almost done, we just have to simplify. So this sine 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2, but it's negative because we're where 210 is. 210 is in the third quadrant where cosine is negative. This one, sine of 30, is 1/2, but again negative because we're in the third quadrant. And a cosine of 45 is radical 2 over 2. The last thing we need to do is just simplify that a little bit more. So the first one, radical 2 times negative radical 3 is negative radical 6 over 4. These things multiply to negative radical 2 over 4. And you could leave it like this, or if you want to write it a little bit more compactly, you could write it like this right here. Everything's over 4, and that should be our answer. Let's just double check. And yes, you can't see it, but that says negative radical 6 right there, so that's exactly what we have. Alright, last two from section 13.3, proving identities. So verify each identity. This is a cosine addition one, so that means we're going to be using this one. And the pattern goes, obviously we start with the more complicated side when proving identities. The left side is more complicated. So the pattern goes cos, this is our A and our B value, cos of the first, cos of the second, minus, because even though that's a plus there, the pattern is minus, minus sine of the first, sine of the second. Okay, so let's remind ourselves, pi, by the way, is the same thing as 180 degrees. Pi radians is 180 degrees. So on the unit circle, here is 180 at that coordinate right there. On the unit circle, that coordinate is negative 1, 0. And remember that the x-coordinate represents cosine, and the y-coordinate represents sine. So what is the cosine of 180, or the cosine of pi? That's the x-coordinate right here, which is negative 1. It's the same thing as negative 1 times this cosine minus, what's the sine of 180, or the y-coordinate 180? The y-coordinate is 0, so that's this sine of pi, sine of 180 is like 0. It's not like 0, it does equal 0. So this whole thing goes away, and we're left with negative 1 times cosine, and that's the same thing as negative cosine. So that is really all we need to do to prove that right there. Next one, or last one from this section, 270, and this time it's a cosine subtraction, so that means this is our A, this is our B. Cosine of the first times cosine of the second. Even though that's a subtraction, the formula for cosine says that when you're subtracting, you're supposed to add the ones in between. So sine of 270 times the sine of theta. Here's our unit circle again to recall. 270 is right down here at that point, and that coordinate is 0, negative 1. So the cosine, or the x-coordinate, is 0. So that means this number right here will be 0 times cosine of theta, which just equals 0. And then we're going to be adding that to the sine of 270. The sine of 270 is negative 1 right there. So that's the same as negative 1 times sine of theta. What is negative 1 times the sine of theta? It's that right there. It's negative sine theta. So at that point we have proven the identity. Okay, so those are the problems from 13.3. In the next video we will move on to the double angle and half angle identities. That's 13.4.